the recording going. Okay, so we are going to be factoring perfect square trinomials. And these are a struggle for people to try to factor. And you can factor it like normal factoring that we're learning about this week, trial and error and the AC method, or there's a shortcut. So I'm going to show both ways.
Right.
But, the shortcut is quicker. So if you can recognize the shortcut, that is to your benefit. Yeah.
As long as you'll accept it, we'll do it.
Okay. So first off, factoring. What exactly is factoring? So we have to look at the word factor to know what that means. So we've used this before, and a factor is a number, or it could be at a quantity, meaning there's variables in it. But it's when you multiply it with something else, it gives you something. So basically, a factor is just numbers that are multiplied together. So if we just look at, like if I have 3 times 15, and that gives me 45. 3 and 15 are factors of 45, because when you multiply them together, they get you 45. And there are different factors, like 9 times 5 also gives you 45. So those are also factors of 45. So factors are things that are multiplied together, but they're also the numbers that divide evenly into something else without a remainder. So factoring is when we take something that's been multiplied and we're splitting it up into things that are multiplied together. So if you were to factor 45, that would be, instead of writing it as 45, you're writing it as 3 times 15. Or you're writing as 9 times 5. So you're kind of undoing the multiplication. So last week, we were learning about how to multiply polynomials. And we had a lot where we had 2 things times 2 things. Factoring is undoing that, where you're taking a polynomial and you're going to write it so you basically have 2 things times 2 things. So we are completely undoing what we did last week, learning how to reverse that process, reverse the distributive property, reverse FOIL. So that's what we're doing. So the most common form here is we have something that's like x squared plus bx plus c, because that's what we're calling a trinomial, because there's 3 terms. And so this generally factors, we have x plus something times x plus something. And then you could have different signs instead of the plus, you could have some minus there then, but that's going to be the basic form. And you're just trying to figure out what are those 2 missing numbers when you're factoring something like this. And we generally do this by guess and check, because if you think about the FOIL process, so if we do FOIL, where we've got something, we usually had an x plus something, x plus something. In order to get, you multiply these 2 missing numbers there, and that was your L in FOIL. That was the last part in FOIL, and that always gave you that constant part when you were multiplying it out. And then if you look at when we were doing FOIL, let me just switch colors here. If you multiplied your inside and your outside, that is what gave you your middle term when you were multiplying it out. So those gave you the O and the I, and that is what gave you your middle term. So when we're factoring, we're kind of reversing that process. So we're looking for those 2 open spots, those 2 numbers that when you multiply them, give you the last number. But when you add them together, they give you the middle number. And that's essentially what factoring is. And this is what we call guess and check, or trial and error, where you're looking for 2 numbers that multiply to the last number and add to the middle. So you have to really know your multiplication tables to do this quickly. Otherwise, if you can't just instantly see what numbers multiply to what you're looking for, it's going to slow you down. And so we've got this chart here of how you figure out what the proper signs are, because a lot of people mess up, how do I know if they're both positive? How do I know if they're both negative? And so I've got this chart that kind of breaks it down. So I've already got videos that go over the whole factoring process in general for trial and error. We're going to be focusing on a specific type, which is the perfect square trinomial. And so we're still going to be basically looking at two things that multiply this, they add together to the middle, but there's going to be some shortcuts along the way. So, but I just wanted to give you kind of brief overview of what exactly it means to factor so that you understand how this works together to, what we're doing here. And we can always check your work after you factor, redo the FOIL process and see if it takes you back to the original problem. And if it doesn't, well, then that tells you factored wrong. So there's a way to check your work by always multiplying it back out. So perfect square trinomials. These are in a very specific form. There's two different ways you can write it. And so you can see it as a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So what this means specifically when we connect this to what we just saw, where we had x squared plus bx plus c. So what this means is that your x squared is something squared. Essentially, your first term is something squared. That's the a squared. The last term, c, is going to be something squared as well. So what's special about a perfect square trinomial is that the first and the last terms are things you can take square roots of. And they'll come out evenly. So like the last term is going to be something like 4 or 9 or 16, these special numbers that when you take the square root, you get a whole number. Then the middle term ends up always being twice, basically. So it's going to be 2 times something times something. So it's always going to be even because it's always going to be multiplied by 2. And then if you took the square root of the first term and the last term and multiplied it together, that will get you your middle term times 2. So there's this pattern, and it takes a while to see the pattern at first. But to see whether it fits into this is that you need to determine the first and last terms. Are they things that are squared? If there's numbers in Miami, you'll take the square root of the number and get a whole number. And they have to be both positive. Then you look, can that middle term be divided by 2? If so, you're good. And then the last thing is to check is after I divide it by 2, is that the result of taking the square root of the first and last and multiplying that? Does that match? And if all of these are true, then you have what is called a perfect square trinomial. And we'll go through this process, when I go through my examples, so you can see and you can help see how to identify whether it's a perfect square trinomial or not. So after you've determined, yes, I have something in this form, then you factor it, and this is where the shortcut comes into play. So a perfect square trinomial always factors into something plus something squared, or something minus something squared. So essentially what it means is that if you tried to factor it using trial and error, you would see that the numbers that you use are identical. So if I go back again, we had x squared plus bx plus c, and this factors to x plus something. Oh, my pen. Oh no, did my pen just die? That would not be good. My pen might have just died.
Battery.
I don't, yeah, this is a special battery. I don't know if I have, let me try to unplug it and plug it back in. There we go.
Oh,
Okay.
there you go.
And it's telling me, yes, it's low. Okay, we'll see how long this lasts me. But when you multiply, your two things together to get C, you'll notice that these two numbers are going to be exactly the same when you try to factor it, on its own. And that's what makes it special, is you basically are using the same numbers there. And so it ends up getting you something that's squared because it's the same thing written twice. And then we always factor out the greatest common factor when we're trying to factor, because that usually makes our numbers smaller. And with smaller numbers, it's a lot easier to find the patterns. So this first example, I'm going to just factor this through trial and error, and then we'll kind of do both at the same time. So we'll factor by trial and error, and then we'll also kind of look at the shortcut and see that, okay, it is in this form. So we've got y squared minus 8y plus 16. So when you're looking at whether something is a perfect square trinomial, you're looking at first, is that first term something squared? So we've got a y squared.
8 squared.
Then you look at that last term, that 16, is that something squared? Well, that is equal to 4 squared. That's something I can take the square root of and get a whole number. So to be a perfect square trinomial, we've got the first kind of thing, that the first and last are things squared. Then you look at the middle. Can I divide that number by 2? So we've got 8. We can divide that by 2. So that is good. That's the second thing that we're looking at when we're trying to determine if this is a perfect square trinomial. And then the last thing is, after you divide that by 2, so if we divide that by 2, we get 4 here. Is that the result of taking the square roots multiplied? So I have y squared and 4 squared. Y times 4 gives me 4y. And those get the middle. And that's what makes it a perfect square trinomial, is that if you identify what is squared on the first and the last, and you multiply it together and then double it, that gives you the middle term. So this is a perfect square trinomial, and we can use our shortcut, but we'll first do it by trial and error to kind of go through the process. So we've got y squared minus 8y plus 16. And with the trial and error, you set up your two sets of parentheses. And then the first parts of the parentheses need to multiply to y squared. So that's always going to be y times y, or x times x, whatever your variable is. Then you look at your signs. So we've got a plus 16. So we've got a positive right there. I should do it in a different color so it doesn't look like I'm also adding a minus. So there we go. I'll just do an arrow. We've got a positive and a negative. So the last thing, the 16, we're multiplying to that, but we need to add to the middle. So we need two numbers that multiply to a positive but add to a negative. And the only way to multiply to positive but add to a negative is if both numbers are negative. Because a negative times a negative is a positive, and a negative plus a negative stays negative. So these are both going to be minus signs here. And if you don't want to think through that, this is what I have on this chart here. So we are, where is it? We are right here in this chart. We've got this form. We have something squared minus and then a plus. And so that means both numbers here are minus.
Ah, okay. That makes sense.
Yeah, so I have the chart so you don't have to think about it, but you can also figure it out by
Yep,
kind
no,
of
I wrote that
thinking
down,
through.
that whole chart. So
Yeah.
that makes sense. Because you have
So
to get a minus and a minus to get 16.
exactly.
Yeah.
So now we're just thinking, okay, what are two numbers that multiply to 16 but add to get 8? So then you just ignore the signs and you think multiply to 16, add to 8. And so you're like, okay, well, I can't do 8 times 2 because that adds to 10, but 4 times 4 gets me 16, and those 4 plus 4 gives me 8.
Yeah, so it's 4.
And so that's the trial and error method, as you're thinking through your multiplication and your addition, and you're trying to figure out what works. Now,
So I'm sorry. So
yeah, go ahead.
whatever, when you're on the first term, they have to add together to make that number. And on the second term, they have to multiply together to make that term. And it has to be the same number or the same numbers.
They don't have to be the same numbers. They just are in this special case because this
So
is
they're
a special type.
factors.
Yeah.
So you can use your factoring chart if you had to?
Yes. Yes.
Okay.
You can use your factoring chart and try to find what are other combinations, because it's not, in this case, they're the same number. They're both 4 here, but that's because we're looking at a very specific special case where they're always going to be the same.
Trinomial square.
Yes.
So, yeah.
Mm-hmm.
So if you ever see this and they're all like even like this, and you look at it and go, oh, they're all like 2s, 4s, 8s, 16s. It's most commonly is possibly with a 2 squared, the exponent.
Yeah. Yeah.
Which most possibly could be this.
Yes.
Okay.
And another thing is, like, sometimes you'll get an odd number, like you'll have 9 in the last spot, but 9 you can take the square root of, so it still might be in this case, but the middle has to be even.
Okay.
So yeah, if you have something where the middle's not even, then don't even bother. It's not going to be the special kind.
It's special term.
Yes. So that's the trial and error method, which is not that hard for something
that's
like
the answer.
this. Yeah, and that's the answer. Now, if we wanted to do this with our shortcut, we start with, we had our y squared minus 8y plus 16. And then by determining, like, we've got y squared, and we discovered, or we figured out, well, that 16 is equal to 4 squared. And that matches sort of our form here. We have something squared and something squared in the first and the last. Y squared, 4 squared. And then we discovered, we were checking that middle term, and that, okay, if I take half of 8, so I have y squared, and I divide that by 2, that leaves me 4y. And so then we see that, okay, my first is y squared, the last is 4 squared, and then the middle is 4 times y, and then doubled. And that's the form that we're looking at here. That is the form of a perfect square trinomial. So I'll just change this. These colors don't work well with my green here. But we have something, we have a squared, and we have a b squared in the back, and then the middle is 2a times b. We're filling in that form. So our shortcut then, as we look on the right, how is this going to look? It's going to be a minus b squared. So you just go to your answer. Okay, a is y, b is 4. I have my minus, and I make it squared, and that's your answer.
Y minus 4 squared.
Yes.
Oh, on the outside.
Okay. Yeah, the square's on the outside.
Because you're squaring both of them, so y needs to be squared and the 4 needs to be squared.
No, if we were to multiply that back out and you do it that way, you're missing half of the problem, because you still have to FOIL.
Oh, okay.
Because that minus in there means you can't just square each one individually.
Right. Okay.
Yeah. So if you were to, you would have to then write it twice, which ends up being what we came up with here. What we did in the
first place.
Yeah, and then you would have to go through FOIL.
Are both of them the same answer though on a test? Say if you did y minus 4, so they would be correct either way you did it.
Yes. Okay. These are the same answer. Just one of them, we wrote it twice versus putting it as squared.
Okay.
So Avery is asking for a second example. Do you want a second example of trial and
Yeah.
error or the shortcut? Because the trial and error, I have a whole entire video on. So I'm not going to do multiple examples of trial and error,
What
but I
about the
will
shortcut?
be doing multiple examples of the shortcut because that's
That would
the
be great.
focus. Yes,
Yeah.
don't worry.
Shortcut is much easier.
Yes, yes. I mean, that's the whole point of this, is showing you the shortcut.
Okay, that'd be great.
Yes.
Okay.
So this one is something that when you've got numbers in front of these things, like it's not just a p squared, you've got this number in front, we usually factor by what we call the AC method instead of trial and error. Because trial and error for a problem like this is really difficult because you've got a lot of numbers that you have to consider. And this kind of problem is where you want to use the shortcut. Like this previous problem, doing trial and error is just as fast if you can do that in your head, and it's less writing things down. But a problem like this, if you can recognize that this is in the form to do this shortcut, that it's a perfect square trinomial, it will save you time.
They're all, no. Oh. 56, 60, 12, they're all, no.
Nope. So yeah, so we've got 36p squared plus 60p plus 25 and big numbers. And so first I'm going to walk you through the AC method to show you how that method works on this problem. And then we'll do it with the shortcut.
Mm-hmm.
So AC method, I'm going to just start by rewriting the whole thing. And so the AC method, how this works is that you take your first number and your last number and you multiply them together.
That's right, I did these.
Yeah, a lot of people really like this method.
It's easier, yeah.
Yes. So I'm going to do that on that one. I'm definitely getting a calculator for that.
Right here.
So 36 times 25 gives you 900. And then you are trying to find two numbers that multiply to 900 and add to 60 here in the middle. And so what I usually do is I'm just like, okay, I know that 9 times 100 gets me 900. I just start with like the first thing that I can think of. And then I'm like, okay, well, can I divide 900 by 8? And I get a decimal on my calculator, so that's a no. So then I'm like, okay, 900 divided by 7, that's a no. 900 divided by 6, okay.
Yeah.
So that's 6 times 150 will get me 900. But that doesn't add to 60. Those are still really bad. And those are actually getting bigger. Those are adding to bigger numbers. So then I might be like, okay, well, instead of doing 9, let's start looking at dividing by bigger numbers. So like 900 divided by 10. Whoops, 10 is 90. And then that still doesn't add up to 60.
12, 13, 14, 15.
Yeah, you're just basically doing guess and check. Let's see, what would help if I typed it in right? 900 divided by 15, that gets you 60. But that adds up to 75. So I need to try a bigger number. So let's say I try 16. Nope. 17. Nope. 18. That gets us close. Okay, that's getting us to 68. So we're getting closer to the 60 that we're trying to do. I do 20, 20.
45 and 20 equals
40.
60.
That gives me 65. That's getting closer. So you're just kind of going, a problem like this, it starts to take a while you're trying to figure out what is the right set of numbers. And let's see, 25 times 36, that adds up to 5 plus 36 is 61. That's going to be close, but that's not right. You keep going, and eventually, I'm going to erase all these things that I've tried, but eventually you're going to discover that
We're not there yet.
Yeah, the correct two numbers that you're looking for are 30 times 30. So
Oh, yeah, but actually, if you think about it, yeah.
yeah, 30 times 30 gets you 900 and 30 plus 30 gets you 60. But you know, when you're doing the AC method and you've got large numbers like this is trying to find those numbers can take a while. You know,
You could have taken off the 0 and looked at 90 and 30, you know, 3
Yes.
times 3 is
Mhm.
9. Then you go, okay, it's 3, you know, 3 into
Yes.
9, then go 30, you know, maybe that might be one way to look at it if it's a number like an even number like that.
Right. Yeah. Any way that works in your head, you know.
You know, my head works, yes.
So then once you discover that pair,
So let's see.
then we're basically, instead of writing 60p, we're going to be writing plus 30p plus 30p.
That's 30.
So we're splitting it up into 4 terms. And then we put parentheses around the first and the last two in pairs, and you make sure you have a plus sign in between.
In the middle.
And then you're looking for the greatest common factor. So the biggest number you can divide out of each pair. And then the first pair generally always has a variable with it. So out of 36 and 30, I can divide those both by 6. I think that's the biggest one.
That's it, yeah. So
And then it's also, I can take a p out because one's a p squared, one has a p. They both have the letter p in there.
then it'll be 6p.
Yep, 6p plus
5.
5. And then
Oh, no p.
Yeah, it has no p because I just removed it.
I would like you guys to send me a very large eraser as part of the gift at Grantham.
And then let's see, the last one, 5.
5.
So this is going to be 5, but not a p because 25 doesn't have a p, and that gives me 6p plus 5.
So let's,
And then when you factor by grouping, what matches in parentheses is your first pair, and then the greatest common factors form your second pair, and that's how you get your final answer.
I like doing these.
Yeah, I like the AC method. It just, in the very beginning, when you're trying to figure out how to split it up, it could take a while.
So, yep, that's what I got.
So
But you actually have a square.
yes. So
Ah.
notice that they're exactly the same. So this means this is this perfect square trinomial. So to use the shortcut on this same problem. So first off, you know, the middle term is even. So that's good. That's the first rule, is that middle term has to be even. So then you look at the numbers. So 36 is 6 squared. So this is really 6p squared, because the 6 is squared and the p is squared.
Yep.
And then 25 is 5 squared. So I can write that. So my first term and my last term are both things that are squared. And then we need to check the middle. So we're going to divide the middle by 2, which gives me 30p. And then you're checking, if I take 6p times this 5, the things that are squared on the outsides, does that give me 30p? And that does. 6p times 5 will get me 30p.
Yep.
So that tells you, okay, this is a perfect square trinomial. And once you identify it's a perfect square trinomial like this, and you can start doing these in your head. You don't have to write these steps once you do enough of them, but you know, we're gonna write them.
I have a quick question.
Yes.
With the 6p squared and the 5 squared, you only get a 30. You keep the 2 as a 2.
Yes, because
You don't add them, don't subtract them, just leave it.
no, the 2 is staying out there because we're putting it in the form of our shortcut here.
Okay, that's what I get. Okay,
Yes, yeah, because
that's why I get confused. What do you do with the extra one?
yeah, the 2 is staying out there so we can see does it match this rule.
Okay.
So once you've decided it matches this rule, then you just go to your answer. So
Which would be the same.
we've got the 6p, and then the inside is plus. So this is whatever your middle term is that matches your sign when you write your parenthesis thing here.
Yep.
And then I take the last number, which is 5, and then it's squared.
And you square it out. Okay, and that's the answer.
And that's
same
the
as
answer.
we got here.
Yes. So I think it's a lot less thinking using the shortcut. On using the AC method, we basically had to go through all of these numbers that multiply to 900. Then we had to split it up. Then we had to find the greatest common factors. And the AC method is wonderful. But
I like
the
it. I like that
shortcut
method better.
exists for a reason.
Nobody has time.
Yes. Yeah. I mean, if you're on a quiz and you have something like this and you recognize that it's a perfect square trinomial, that you can use this shortcut, use it.
Right.
Because it will save you time. So these are all going to be in this form, but we'll double check, show you how you can figure out it's in this form and everything. And I've got the 2 shortcuts here where basically once you recognize it's in the form, it's either going to be something plus something or something minus something squared. And that whether it's plus or minus depends on the sign of the middle term. So on the left, I've got 4y squared plus 20y plus 9. And so we always first check is that middle term even? Yes. Because if it's not even, well,
it's
don't even
no
bother.
longer a perfect square trinomial.
Exactly. So once you determine that, then you figure out, okay, first, is that something squared? So 2 squared gets me 4. So that would be 2 times y squared.
9 would be
and 9 is 3 squared. And once those 2 match, or those things are squared, because if those fail, then don't even bother in the middle,
Right.
Then you're checking, okay, if I basically factor out a 2 out of that middle term, which will give us 10y, which I must have.
And they're all pluses, so we don't worry.
Yeah, they're all pluses in here. And I must have typed this one wrong because this one actually is not a perfect square trinomial. I meant to make one a perfect square trinomial. I must have typed it wrong.
Because of the 3?
Yeah, because they're supposed to multiply 2y times 3 should give you the middle, which would be 6y, but it doesn't. So this is actually an accident, a happy accident, because this shows you.
So how would you answer this?
So first, this is
still do that.
Yeah, so this is not a perfect square trinomial because it doesn't give us 6y there.
But is it solvable?
That's the next question. So then you have to go to yourself and go and say, okay, well, let me try the AC method, or let me try factoring, by trial and error to see. So if you think, okay, this might be a perfect square trinomial, I'm going to go through this process, and you find that it's not, then you have to go back to one of your other methods here. So I'm going to try to
you just start back from the beginning again?
Yeah, you start back from the beginning. I'm going to just try to do trial and error here just for quickness sake.
Right.
Let's see. So if I tried, because that would be quicker for me. Plus, I don't have a lot of space here. 18. So this can be factored. It's just not a perfect square trinomial. So if you factored by trial and error like I did, the first and the 2y times 2y gets you 4y squared. Nope, this doesn't work because that would give me 18. No. Let's see. So
20.
Let's do 4 and 1 times 4 is 12.
4 and 5
times 4 is
4 and 5.
6. But see, I need to multiply to 9. I don't think this factors.
It doesn't. No.
Yeah, I don't think it does. So I think if you tried one of your other methods, you would find that it doesn't work. And so we can't factor it, and we say that it is prime.
Yeah, those are tricky.
Those are tricky.
And you're like,
yeah.
Oh,
You only figure it out when you try and it doesn't work.
It's frustrating because you're like, there's got to be an answer. And it's funny because the way it's laid out in the test is the answer is only put into exponent or prime. Like
Mhm.
they're telling you that these are your only two options.
Yeah. So it might be prime, but you have to try.
Right. So you have to really decide, because if it's not going to be prime, it's not in there.
Right.
Right. So it's like, and I've guessed a couple because I'm like, I can't figure it out. And then they go, it's not prime. I'm like, oh, back to the drawing board.
Yes.
Okay.
Yeah.
So
Yeah.
good.
So
okay.
so if it doesn't follow the perfect square trinomial, and here it almost did until you think, oh yes, and then it's like, nope, you got to do that third check. Then you have to go back to your regular factoring.
Oh, good.
Now this
And
other
now-
one definitely is.
Okay. Yeah.
So I've got 4 plus w squared minus 4w. We have to rearrange this
Yeah.
before we check. So I have to put that w squared first, because in its current order, it's not going to be in the right order in order to determine if it's a perfect square trinomial. So I have to put that w squared first, then the minus 4, and then plus 4 at the end. So that middle term is even, so that's good. We've obviously got w squared. And then that plus 4 is 2 squared. So I'm going to rewrite that. So that so far so good. The first and the last are squared. And then we want to take that middle and factor out a 2, basically divide it by 2, which leaves us a 2w. And this one does follow our rule. Because w times 2 gets us this 2w there when I factor out that 2. So then that means your answer is w, and then we have a minus because the middle term is minus, and then 2, and then squared.
Squared. Yep. And then if you did it the other way, you get the other ones. Okay, that one worked.
Mm-hmm.
That one worked.
That one worked. I'm not even sure what I was trying. Instead of 20, what would I have been?
It was actually good to see that you couldn't work it out, so that we know
Yes.
there are sums that don't, even though that middle number is, but that 9 is where it throws off. They all have to kind of be evens. Does it work with odd numbers if all of them were odd?
No.
Like
Well,
if 3 and 18, a 3.
The middle, the middle always has to be even. You could have the first and the last be odd if they're both perfect squares, and then the even was the right number.
Okay, the 3 threw it off because it was a 9. Let's see if what number would make that actually a perfect square if it was not a 9?
If it was a 25, because then we would have had a 5 there, and 5 times 2y would get us our 10y.
Okay, got it. So it would be a 5. So just a mistype. But it was a happy, it is a happy accident.
Happy accident.
For me, it is to see that sometimes they are not solvable and stop beating yourself over the head.
Right, because sometimes that happens. Now we don't try to do that often to you guys, but it does.
But it's good to know, and I like the fact that it didn't work out in a way.
Right.
Okay.
All right. So I've got 2 more examples, and these are, bigger numbers and with multiple variables, so that whoa, wait a minute, we've got more than one letter here. What do you do in those
situations? That's my other problem.
So both of these these should both be, these both are perfect squares. So
there's that 9 again, but there's a 25.
Yeah. So, and this is one of the situations where the first and the last are odd numbers, but these are still perfect squares. So that middle term is even, so that's good.
So we times 25 times 9.
Yeah. So we've got a 25, so that's 5 squared, and then I have an m. So that would be 5m.
Oh, we're doing the shortcut, right?
We're doing the shortcut, yes. And then we're going to check, 9 is 3 squared. So this is going to be 3 and the n are both squared. So I'm putting those in parentheses here to indicate that both of those are squared. So far, so good. The first term and the last term are perfect squares. They're things squared. Now we're going to take that middle term and factor out a 2, which would be a 15mn. And then we're checking, okay, can I get that by multiplying my first and my last? So I have 5m
Times 3.
times 3n. So that gives me 15. And then I have an m and an n.
Yep.
So that works. So then I just go straight to my answer here. I have 5m and then another minus. Why did I make all these minus? I'm going to make the next one plus there. So then it's a minus because our middle term is minus, and then 3n squared. And I think it's, if you try to do this
much more understandable this way.
Yes, you could do the AC method on this, but it is going to involve a lot more work. But of course, not everything falls into this situation, and then you have to do the AC method if it doesn't, you know, to see if it factors. So the second one here, I've now turned that into a plus for getting some variety. So we have 36p squared. We made that a plus.
Use the whole pencil so far.
24pq plus 4q squared. So middle, that 24 is an even number, so that's our first check. Then we need to see, okay, what do I have squared? So like 36 is 6 squared, so that's going to be 6p. And then I've got my 24pq. And then 4 is 2 squared, so that's going to be 2 and q are squared there. So that's good. The first and the last are things that we could square. So if it was like 5q square, that would fail because you can't take the square root of 5. Right. So, you know, or at the beginning, you might have had the p squared, but if it was like 15p squared, that doesn't work because that 15, you can't take that square root of.
Right. I think I actually got the next part.
So I'm just going to check. Okay, if I factor out a 2 in the middle, I've got 12pq.
12 and 12 equals 24.
And so that works out.
P plus 2q.
6p times 2, 6 times 2 gives me 12. And then I've got a p and a q. And so we would write, oops, somehow.
The pen again.
Yes. And then we get 6p plus 2q squared.
Right, I got it right.
Now, this one I have a little trick in here. Because while, yes, technically this is the correct factor, this is not what we call factored completely. So you have to pay attention to that, especially in like Connect Math, if you see the words factor completely. Because notice that 6 and 2 have a number in common.
Which is 1, 2.
I can factor a 2 out. So if you get to the end and you notice, oh, wait a minute, they still have something in common, that tells you that you needed to factor out the greatest common factor first. That you didn't, you know, and that you missed something, that it's not done. So let's do that. Now you can keep what you did on your notes, you know, obviously, as a check, you know, to tell yourself, oh, they still have something in common, so we missed something. So go back to your beginning. I can divide all of those numbers by 4. 4 goes into 36, 24, and 4. So we always need to check to see if there's a greatest common factor. And sometimes you get so into this that you're like, you skip that step, you forget. And then you get to the end and that's where you're like, well, wait a minute here. So if I factor out of 4, 36 divided by 4 is 9. So I get a 9pq plus 24 divided by 4 is 6.
Or you can do the middle one.
Yeah. And then 4 divided by 4 is, yeah. So I've got 9p squared plus 6pq plus q squared.
That's q squared. That's what I got.
Yeah. Now, this is still perfect square trinomial. So it doesn't change that fact. We can still use the shortcut. We just needed to take a 4 out first, and it gives us smaller numbers to work with. And so the 9 is 3. Oops, I need to make sure I don't switch my letters. P and Q. So instead of like we had 36, which was 6 squared, now we've got 3 squared, which gives us our 9. And I'm just going to already divide out the 2 because I know this is a perfect square trinomial. So that would be 3PQ. And then of course, Q squared there. And so this, for our perfect square numbers, all of our numbers now are smaller. We're looking at 3P times Q, which gives us 3PQ in the middle.
Factor, no.
So we have, when we do the perfect square trinomial with this 4 in front, the 4 stays there. And then we have 3P plus Q squared as our final answer. And now if you look at it, the 3P and the Q, there's no number in common. So that tells us, okay, we did indeed factor as much as we could.
4 times 3. What happened to the 2 times 3? Did we factor that out?
So
where the 24 came down to 6 to 2.
Yeah, so the 24 came down
So
to
it's
6
gone.
because we divided by 4, we factored out a 4. And then when we're using our shortcut, we're just looking at the 9P squared plus 6PQ plus Q squared.
So then we divide it by 3.
We divided by 2, and that
2.
gave us our 3PQ to check that it is in the correct format.
Okay, 4, the 3, you took the, okay, I got it. I got what you did.
Now, this is equivalent to what we did before. Before we had 6P plus 2Q squared when we didn't factor out that greatest common factor. And if you notice that, you know, and you're like, oh no, what you can do is say, okay, out of 6P and 2Q, there was a 2 in common.
Yeah, that's what I did.
So that gives me 3. So I can factor that out in the parentheses here.
3P.
And that gives you, I'm mixing up my P's and Q's.
Mind your
P's and Q's, exactly. So I can factor that inside the parentheses here, where that's 2 times the 3P plus Q. And then to take it out of the parentheses, that 2, to get it out, gets that exponent of 2. So that becomes 2 squared times 3P plus Q squared. And that's how we end up then with 4 in front in the 3P plus Q squared.
And we keep it squared at the end also because you're squaring the 2 and you're squaring the... Okay, got that.
So it's equivalent. And if you didn't notice the greatest common factor, you can get to the same result. It just takes a little bit more work, finagling with your answer to get there.
I understand.
So what I recommend doing is just always try to remember, check the beginning. Is there greatest common factor to factor out first? It won't mess up whether it's a perfect square trinomial. It will be, or it won't be. It's not going to mess that up. And it will still allow you to do the shortcut, but then it just makes the number smaller. And then, you know, you won't get any issues in Connect Math when it says, oh, it's wrong, because it's just not all the way done, you know?
Well, if it's not all the way finished, they do tell you.
Yeah, they usually will tell you. Now, they won't tell you on a quiz, obviously. Yeah.
Continue. You're on your way, basically.
Yes. Yes.
Just say, keep going. You got it, girl.
Mm-hmm.
All right. That seems more explainable. Thank you.
Yes. So that was my last example here. So that's the perfect square trinomials. And of course, these are just special cases. But if you notice them, it does make things a lot easier for you.
Yep. I'm sure there'll be 1 or 2 on the quiz.
Yes. We usually put one of these, either the difference of squares or a perfect square trinomial.
There we go.
Most often the difference of squares pops up because that one actually shows up a lot more. So, but you can get either one of these. But we do like
Okay.
to put one of the special ones on the quiz for you.
Perfect trinomial square. Perfect. Okay.
Yeah. So any questions?
No, you've been great. Everything looks very, very more understandable to me, at least.
Mhm. Now, these specifically, why we're even spending time on learning this shortcut, other than just, saving yourself time, is when you go to college algebra, you learn something called completing the square. And that's where you create something like this. You're like doing some math to make it in this form to make your factoring easier. And that's something that's actually a trick that's used for those that have to go on to calculus. Anybody who's in engineering, you'd better need to know how to do this because you're going to want to do this.
I'm not going to be an engineer.
Yeah, if you're not going to be an engineer, then this is just going to save you time. But if you're in engineering, this is something that will pop up and it will definitely be something that you need to know how to factor. So,
All right.